Is programming really just another subject, or is there more to it? In this video, I am going to reveal, why isn't programming like other subjects, what makes programming unique, and why should you, as a coder, pay attention to this. But first, let us see how people commonly see programming. Programming is commonly seen as a technical skill, one that is grounded in mathematics, logic, and structured thinking, which involves elements such as algorithms, data structures, and computational theory. And it's fair because at the end of the day, programming at its core is about solving problems through code. To do this effectively, you need to apply logical reasoning and a strong understanding of how computers process information. But what if I told you programming goes far beyond normal convention and domain of subjects? And it requires much more than just knowing how to write code. We will explore that in a bit. But first, there is another crucial perspective that is part of a big picture but often overlooked, and our potential suffers because of it. When you sit down to write code, you're not just inputting data into a machine, you're crafting a solution, designing an experience, or even telling a story. Now, you would be thinking, how is that compared with telling a story? But you would be amazed to see there are quite some parallels between them. Let me explain. When you start with a concept or a problem that you want to solve, and as you develop your code, you create characters, variables, plot twists, conditional statements, and resolutions, functions and algorithms. But there is a chance that I might be just delusional about this. For that, here's something better. When you sit down to write code, you're crafting something new, something that didn't exist before. You are literally creating value out of thin air. Yes, sure, it is because of people that came before us, but still it is something to create that can impact millions of lives with writing symbols on screen. Whether you're designing a sleek user interface, developing a complex game, or creating a powerful data analysis tool, programming gives you the power to bring your ideas to life in a tangible and interactive way. Just as a painter chooses their colors and brushstrokes to create a masterpiece, a programmer makes choices about how to structure their code, what design patterns to use, and how to optimize their program's performance. These choices are often driven by aesthetic considerations as much as by technical requirements. For example, a well-written piece of code is not only efficient and functional but also elegant and readable. It's crafted in a way that other programmers can understand and build upon. Remember, I said that by overlooking this perspective, your potential suffers. Here's why. Viewing programming as an art empowers individuals to see themselves not just as coders, but as creators. When programming is viewed through the lens of both science and art, it encourages out-of-the-box thinking. This mindset is crucial for innovation, as it drives programmers to explore unconventional solutions and push the boundaries of what's possible. By recognizing the artistic aspect of programming, individuals are more likely to take creative risks that lead to groundbreaking developments. Moreover, the process of programming often involves a high degree of experimentation and iteration. Much like an artist might sketch out multiple drafts before settling on a final composition, a programmer might write and rewrite their code several times, testing different approaches and refining their solution until it meets their vision. Remember, I told you in the beginning that programming exceeds normal convention and domain of subjects. It requires much more than just knowing how to write code. Here's the reason: programming is a multidisciplinary adventure that crosses into a variety of fields, requiring a broad and versatile knowledge base. Take mathematics, for example. A strong grasp of mathematical concepts is essential for developing efficient algorithms, optimizing code, and solving complex computational problems. For instance, understanding graph theory can be crucial when working with networks, while probability and statistics play a significant role in machine learning and data science. Then there's engineering, where programming becomes the backbone of developing systems that are reliable, scalable, and efficient. Software engineering principles guide the process of designing, testing, and maintaining code, ensuring that it can stand up to real-world challenges. Concepts like version control, continuous integration, and software architecture are deeply rooted in engineering practices, making programming an integral part of creating robust and high-quality systems. Design is another field where programming's interdisciplinary nature shines. When you're creating a user interface or crafting the user experience, a deep understanding of design principles is just as important as knowing how to code. It's not enough for a program to work, it has to be intuitive, aesthetically pleasing, and user-friendly. This means thinking like a designer, considering layout, color theory, typography, and the way users will interact with your software. The intersection of design and programming is where art meets technology, resulting in products that are both functional and beautiful. But the reach of programming doesn't stop at the technical and artistic. It also extends into the social sciences, where understanding human behavior, psychology, and societal trends can be crucial. Consider the development of social media platforms, online communities, or educational software. Each of these requires insights into how people think, communicate, and learn. By integrating principles from sociology, psychology, and education, programmers can create software that is more engaging, effective, and responsive to users' needs. In essence, the interdisciplinary nature of programming means that a programmer must be more than just a coder. They sometimes need to be a mathematician, an engineer, a designer, and a social scientist, depending on the situation. This blending of disciplines is what makes programming such a dynamic and exciting field, offering endless opportunities to innovate, solve problems, and create tools that have a meaningful impact across a wide range of domains. At this point in this video, you could already guess why you should be paying attention to this. But there is the most important fact that programmers must keep in mind. Technology is not just about efficiency and functionality, but also about enhancing human experiences and solving real-world problems in meaningful ways. This understanding encourages a more thoughtful and ethical approach to programming, where the impact on users and society is considered alongside technical considerations.